Welcome to ID the Future, a podcast about intelligent design and evolution.
Hello, I'm Eric Anderson, and today on this episode of ID the Future, I'm pleased to be joined by Dr. Michael Denton for our first of multiple interviews about his new book, The Miracle of the Cell. Dr. Denton holds an MD from Bristol University and a PhD in biochemistry from King's College in London. His previous books include Evolution, a Theory in Crisis, and Nature's Destiny, How the Laws of Biology Reveal Purpose in the Universe. His work has been published in Nature, Nature Genetics, Biosystems, Human Genetics, and Biology and Philosophy. Joining us all the way from Perth, Australia, welcome, Mike.
Thank you, Eric. It's a pleasure to be here.
As we begin, I think it would be remiss if I didn't mention that your book, Evolution, a Theory in Crisis, is one of the classic works that really sparked a revolution in this area, as you dared to question the prevailing thinking at the time and considered the possibility that something more fundamental was going on in biology than just a mindless, random, purposeless process. That was in 1985, I believe, and then you followed it up in 1998 with Nature's Destiny, and now this new series, Privileged Species. That's been quite a journey for more than 30 years.
It certainly has, Eric, actually, but it's actually closer to 50 years.
Okay.
Okay. Yeah, my skepticism about Darwinism began many years ago when I was studying the development of the red blood cell for my PhD at King's in London in the late 60s, early 70s. And what I realized as I was working on the red development of the cell was that the final event in the development of the red blood cell, which is the ejection of the nucleus, which results in the mature enucleate iconic biconcave red blood cell, was simply impossible to explain in Darwinian terms.
Mm-hmm.
It seemed to me there was no way in which one could explain how the red cell lost its nucleus gradually via a series of small adaptive Darwinian steps. It seemed to me that the nucleus had to be in or out of the cell. I could not conceive of any reasonable intermediate state.
Yeah.
At the time, King's was basking in the afterglow of the discovery of the double helix. All my colleagues at King's were ardent materialists, reductionists, and Darwinists to a man, but none could provide a Darwinian account of the ejection of the nucleus or explain how it might have come about via a series of gradual evolutionary steps. And it was this basic realization that the loss of the nucleus could not be explained in terms of classic Darwinism that really activated me to get started with a critical review of the entire Darwinian paradigm. And the outcome of that work was eventually Evolution, a Theory in Crisis, which was published in 1985.
Yeah, that elimination of the nucleus in the red blood cell is a pretty remarkable process.
It's an amazing process, and you can't explain it in terms of Darwinism at all. Yeah.
Mm-hmm.
Now, my other major interest is in the fine-tuning or fitness of nature for life as it exists on Earth. I got interested in this area about the time Evolution was published on reading Paul Davies, Martin Rees, and other physicists who were actively pointing out in the 80s and 90s just how exacting the fine-tuning of the physical constants had to be to generate a universe suitable for life. At the same time, I also read Lawrence Henderson's great classic, The Fitness of the Environment, and was this book, perhaps more than any other, which really motivated me to enter the fitness debate and to prepare the first drafts of a book which led eventually to the publication of Nature's Destiny and eventually to the Privileged Species series of monographs, and this, the latest monograph in that series on the cell.
Yeah, that's a remarkable journey. And in addition to biochemistry, I think you have some experience in the medical field. When we talked the other day, you shared with me an experience that you had while working alongside intensive care physicians in Sydney in the 1980s. If it's not too personal, would you mind sharing that with our listeners?
Sure, Eric. I'd be very happy to do that. Yeah, the experience occurred while I was working in intensive care medicine in Sydney in the 1980s. It was working in that area when I first came to realize the extraordinary mutual fitness of the properties of some of the key substances, such as oxygen, carbon dioxide, water, and bicarbonate, which maintain the normal physiological functioning of the body. And it occurred to me, and I realized quite forcibly, that without this unique mutual fitness, there would be no advanced life on Earth, and certainly no intensive care physicians.
Right.
I recall many occasions, sometimes alone in the small hours in the hospital, when meditating on the remarkable life-giving fitness of the properties of these key players underlying our physiological design, I had the powerful feeling that the mutual fitness of these basic constituents simply had to be the handiwork of an intelligence, which had our being in mind from the very beginning, the very moment of creation. It was a very powerful, intuition. And it gave me, at times, a distinct and somewhat eerie feeling of being in the presence of an intelligence which had long before preordained the world for the coming of mankind.
That's a really remarkable experience. I appreciate you sharing that. I can imagine desperately trying to help someone whose life is in the balance and understanding all the things that have to go just right with all of these elements and molecules and systems, and feeling like someone's been here before and knows how this is supposed to work.
Exactly. You put it very well, Eric. Yeah, exactly. Yeah.
Now, in Nature's Destiny, you began to explore in detail some principles of physics and chemistry and the properties of the elements, and you argued, if you'll permit me to quote a passage, that the cosmos appears increasingly to be a vast system finely tuned to generate life and advanced biological organisms very similar, perhaps identical to ourselves. There's been an explosion of additional research in the area of cell biology, our understanding of cellular systems, and the exquisite operation of living organisms. How has your original thesis fared over the past couple of decades? Do you feel that new discoveries have challenged fine-tuning, or have they corroborated the idea that we live in a fine-tuned universe in a fine-tuned world?
Okay, well, I can't comment professionally on recent cosmological discoveries, but my impression on reading books, for example, like Luke Barnes' A Fortunate Universe, is that the more we understand of the structure and evolution of the cosmos, the more extraordinarily exacting the fine-tuning for life appears to be. And turning to biology, I think there is little doubt at all that the fitness paradigm has fared very well over the past 2 decades. No single advance in knowledge that I am aware of since I published Nature's Destiny could possibly be construed as in any way undermining the fitness paradigm. Moreover, during the past 2 decades, new advances have provided further support for the unique fitness of nature for life. One fascinating example is the discovery of the fitness of various quantum phenomena, such as quantum tunneling, which plays a vital role in electron transport and enzymic catalysis. Another example might be the discovery of increasing numbers of basic organic building blocks of life, identified in space and in meteorites, including amino acids and nucleotide bases.
Yeah, these are really great examples, and I'm looking forward to talking about these in a little more detail. I feel like your most recent books really bring the argument closer to home, so to speak. From talking about the universe and the broader principles, your new series of books, as the series title suggests, focus on us as a privileged species, specific characteristics of our planetary environment that allow us to live here on Earth, our ability to harness fire and remake the world, the unique properties of water that enable and sustain life. If you could describe briefly the first 3 books and why privileged species is really an appropriate description for these lines of evidence.
Yes, okay. My first book in the series, Firemaker, focused on the fitness of nature for the development of technology by being similar to modern humans. The second book, The Wonder of Water, described the fitness of water for the cell and for many phenomena vital for the life of advanced terrestrial beings, sharing our biological design. The third book, Children of Light, described the fitness of nature, and in particular sunlight for photosynthesis. All of these books highlight the remarkable fact that many elements of fitness of nature are specifically fine-tuned for our type of biological being. So privileged species is an entirely appropriate description of the evidence summarized in these 3 books.
Yeah, that's a great description, privileged species. And your 4th book in this series, The Miracle of the Cell, came out just a couple of days ago. I've absolutely loved reading this book, Mike, and while I've been reading, my wife in the other room next to me keeps hearing me exclaim, "What? Are you kidding me? That's incredible." So as we get ready to dive into some of these amazing details, first at a high level, what would you say is the main thesis of your latest book? What was your goal in taking this fine-tuning argument all the way down to the level of the cell?
Yeah, well, the main aim of the book is to show that the properties of many of the atoms of the periodic table, about 20 in fact, which is about 1/5 of the total, possess what can only be described as an extraordinary unique fitness to serve a number of highly specific biochemical functions essential to the existence of the carbon-based cell, which is, of course, the basis of all life on Earth. And this fitness, and this is very significant, of course, long predates the existence of the first cell, and implies that the basic design of the cell is not the result of blind, undirected Darwinian processes, but was built into nature from the moment of creation. Given that cells are the basic building blocks of all life on Earth, including advanced forms such as our cells, then it would have been a really serious omission, I think, to have left out of the series of monographs one devoted to the fitness of nature for the cell. So a miracle of the cell had to be included. Moreover, describing the unique fitness of the atoms for life allows us to extend the notion of a unique fitness for life in the order of things from the grand cosmological constants, which determine the overall structure of the cosmos, to the individual atoms of the periodic table, which determine highly specific, vital functions upon which the life of the cell depends. In other words, the miracle of the cell, if I can put it like this, it completes, as it were, the overall fitness paradigm. It unites galaxies with the atoms in a vast web of fitness for life.
That description, if you start with the universe and then look down at the atomic level, we seem to be situated somewhere between the two, and both of those are pointing toward us in the middle here.
Yeah, that's right. Yes. The cosmic constants point towards stable solar systems and planets like the Earth. And the atoms point up to beings like ourselves. Yeah, that's right.
So let me ask you to help us with this definition. You talk a lot in your books about fitness of water, fitness of the elements, and so on. Some listeners might be used to hearing fitness discussed in an evolutionary context in terms of organisms competing with one another. But it seems to me that you're using that term in a more fundamental sense, that a particular element or a particular substance is fit, well suited, we might say, for a particular task or a particular role in the unfolding of life. Is that the right way to think about it? What do you mean when you talk about fitness of the laws of nature or fitness of the elements?
What you say is about right, Eric. Because when I talk about fitness, I'm talking about the underlying fitness of the basic laws of nature or the properties of matter, which have enabled the actualization of biological innovations such as the carbon-based cell, photosynthesis, the circulatory system, or vision or air breathing. In all such cases, many exacting preconditions must be satisfied in nature to enable their actualization. It's just like when you bake a cake, you need the right ingredients before the recipe can be followed. And if it isn't followed properly, then the cake can't be baked.
Right.
Yeah.
Yeah.
By the way, I have never baked a cake. But I have watched people bake cakes, and I'm pretty sure you need the right ingredients.
Yeah. So building on that just a little bit, you talk about the fitness of the cell, but also the prior fitness of the many atoms in the periodic table, the fitness of water, the production in outer space of molecules that are important for life. And you refer in the book to these complementary characteristics as a unique fitness paradigm. And you quote Henderson, who said that the entire cosmos seems to constitute a profoundly biocentric whole. Help us understand what he meant by that.
Okay. Well, the impression that the cosmos is a profoundly biocentric whole, as Henderson claims, I think this arises from any serious consideration of the staggering number of diverse phenomena and natural processes, including sunlight, the viscosity of crystal rocks, the viscosity of water, properties of transitional metals, heat capacity of the atmosphere, the strength of chemical bonds, the thermal properties of water. It's endless, the hydrological cycle, plate tectonics. In all these cases, these phenomena and processes have to be exactly as they are for life to exist in the cosmos. Mm-hmm. If they differed in any way, even slightly, there would be no life in the universe and certainly no advanced forms of life like ourselves. Consequently, the impression it created is that virtually every aspect of the natural world has been fine-tuned for life. And there was a famous quote from Freeman Dyson when he summed up the situation, when he said famously, the universe must have known in some sense we were coming. So, yes, everything points to the universe being a profoundly biocentric whole.
Yeah, and I love that very evocative phrase from Dyson, that the universe must have known in some sense we were coming. That's beautiful.
Yeah.
So in chapter 1, you talk about the astonishing complexity of the cell, and you suggest that there is likely far more complexity still to uncover as you compare looking ever farther into the reaches of the universe to gazing ever deeper into the cell. Again, those two extremes that we talked about. Why do you think there's still more complexity to uncover?
Well, basically, because, in fact, throughout my academic career, in every decade, from the discovery of the double helix in the 1950s up to the present, new discoveries have continually revealed ever greater depths of complexity in living systems.
Mm-hmm.
To take some examples, recall that for years, genes were thought to be contiguous sections of DNA. Then in the 1970s, introns were discovered, and the mechanism of gene expression became far more complex, as it necessitated the excision of the introns from the initial transcript of the gene. Again, RNA was long thought to be a passive carrier of genetic information, until it was discovered in the early 1980s that it was also capable of enzymic catalysis. Again, certain protein molecules, initially thought to interact with one or two binding sites in DNA, have subsequently turned out with further study to interact with thousands of different sites in the DNA. And there again, the DNA in the nucleus, once conceived of as a relatively simple linear double helical structure, has been shown recently to adopt a vast number of unique, vastly complex, three-dimensional convoluted topologies, which play a critical role in the control of gene expression by bringing together distant sections of the linear helix into close proximity. Now, Jennifer Doudna, she summed up the situation. She was the researcher that discovered CRISPR-Cas9, now widely used in gene editing. She referred recently to the discovery of ever-increasing levels of complexity in the cell in a Nature article. In her words, she said, "It seems like we're climbing a mountain that keeps getting higher and higher. The more we know, the more we realize there is to know." And already, from what we know at the moment, I think the cell can be said it's almost inconceivably complex. It's a genuine infinity, another infinity, yeah.
Yeah, kind of an endless reverse engineering project that we've embarked on.
Yes, exactly. Endless. Endless is the word, yeah.
Well, Mike, this has been fascinating. Unfortunately, that's all the time we have for today. Thanks so much for being here to share this important topic. And if you don't mind, I'd love to have you back to tell us more about some of the amazing atoms that work in the cell.
Yeah, this is just the beginning, Eric. There's much more to come. Yes.
Excellent. Well, we've only had time to hit a few of the highlights today, and the real fun is in reading the book and digging into the details. Get your copy of The Miracle of the Cell today in paperback or ebook format at online retailers like Amazon and Barnes & Noble. Until next time, for ID the Future, I'm Eric Anderson.
This program was recorded by Discovery Institute's Center for Science and Culture. ID the Future is copyright Discovery Institute. For more information, visit intelligentdesign.org and idthefuture.com.